Hi guys and gals and kittens, and welcome to the Ainiro Magic Show. So I've just been cooking a new Hyperlambda generator, and let's try it out, see what we can get out of it. And I wanted to do this without actually using an orchestrator AI. Why? Because you can actually download Magic from GitHub, clone it locally or whatever, and use this straight out of the box, no API keys required. And that allows you to play with the Hyperlambda generator and test it the way I'm doing. And that actually allows you to use AI to build a complete API and backend, the entirety. You just don't have the orchestrator to help you create the prompts, which makes the task much more demanding from you. But still, it is possible. So let me show you a little bit about what you specifically can do, right? So here I'm inside of, create Hyper ID, clicked modules, expanded modules, created a new module called test, and I created a file called test.hl. Right now, if I click Option Q, I get this dialog box back again. So let me write into the description. Executable Hyperlambda file that does the following: opens up database connection to Chinook SQLite database, retrieves 15 rows from artist table, returns to caller as artist rows. Now if I click save and generate, right, it's actually using the Hyperlambda generator. It's using my LLM. So let's see, because I also want to see the effect of this fine tuning, because this is the first fine tuning where I have 155,000 synthesized prompts based upon 100% correctly, mathematically correct code randomly assembled, which was the point where I basically completely exhausted the problem domain of Hyperlambda as a whole. Now, of course, if I execute this code, it returns 15 rows from that. Let's see what more it can do. Okay. Creates HTTP endpoint that takes name, first name, last name, and email address, and pushes to HubSpot as new contact. Use the configuration key found at magic hubspot.key. So now, if you know the basics of system development in any, doesn't matter what programming language, you can easily reproduce this, right? What I wrote. At which point the system's just going to magically assemble whatever you write into it, assuming it is within the problem domain of Hyperlambda. Let's do something else, something more complex. Invoke the API at foo.com/contacts. The above API returns a list of contacts as an array of elements resembling the following: array of elements where each individual element resembles the following: name, John Doe, email, john@doe.com. I want you to transform the result into a CSV file you save to etc. TMP with incoming email taken from email and full name from name. Before you save the file, encrypt its content, its CSV content, using AES with password. This is super secret. And there you go. Content, yeah, so it transforms into CSV content, the list of the array list given by the endpoint, maps it. This is actually wrong. So, because it's supposed to actually, this is wrong. Okay, so it failed. Let's see what more it can do. Fetch my last 10 emails from Gmail using OAuth. Assume configuration keys found. Assume a configuration exists from before and use fabricated configuration keys. I will replace these later. Let's see if it succeeds now. It did not succeed on the previous task, I need to emphasize. So it's not perfect, and the reasons for that is because although it knows the problem domain of Hyperlambda 100% and is arguably the first LLM in the world to actually know the entirety of the problem domain, okay, so now it just completely hallucinated too. Okay, so now we know we can't do that, right? But let's see what the other stuff we can do. Load the CSV file at etc. temp contacts.csv. Encrypt using AES and password found in configuration key magic AES command. Return to caller as encrypted content. So even though I've completely exhausted the problem domain of Hyperlambda, I still haven't exhausted every potential workflow. And that is basically me needing to sit manually and create Hyperlambda code. I've already got, 17,000 roughly different structures, but none of these structures exists, right? But I got enough close structures for it to most of the time, assuming I don't provide too much complexity at once, get it to accurately generate whatever I ask it to do. So now at that point, the only question becomes, what can you do with Hyperlambda? Well, if you click AI support here and you ask this thing, let me restart this one again before I do that because it failed. And you ask it, what things can I do with Hyperlambda? Now we can actually read this. So it loads the CSV file, gets the password from configuration, then encrypts it using AES 256, and it yields it as encrypted content. 100% correct code, 100% correct. Let's try to combine something more. Return top 5 rows from Chinook database and artist table. Transform result into CSV. Encrypt the CSV content, save to random file name in etc. tmp folder. What I'm trying to do here is to show its abilities to actually generate workflows. Data read artist 5 transforms it to CSV correctly. Here it correctly generates file name with .enc extension. Okay, I'd rather choose CSV, but I mean, that's a matter of taste. I actually didn't specify that. So it is correct. It completely, yeah, and here it even saw that the prompt lacked password, right? Because I didn't tell it. If you see what I wrote to it, let's replace the comment with my prompt comment. I actually didn't specify password, so it just made up a bogus password here, right? But this is 100% correct, right? So that, I mean, the thing it cannot do absolutely everything that Hyperlambda can do quite yet, but it's fairly impressive. And this workflow here that I just now generated, which I'd say is a fairly complex piece of code to manually write. My inference costs for that code is like 0.15 cents, roughly, right? Later, when I switched to Gemma 4, running my own LoRa model, even at the hosted LLM API provider, I will end up paying like 0.01 cent for this request, roughly. And, you know, you see the speed of the thing, right? 1,000, 2 1,000, 3 1,000, 4 1,000, 5 1,000, 6 1,000, 7, 8, 9, 10. Well, I guess now you don't see the speed. On average, it takes between 3 to 5 seconds. But every now and then it messes up, right? And then sometimes OpenAI's HTTP connection is garbage. They have some bugs in like that just like swallows the connection and kills it. Now it actually succeeded. So, but on average, it takes 3 to 5 seconds, right, to generate code like this. So, anyways, thanks for watching. Have a nice day.